Good evening. Welcome to a special video discussion about the winter storm or lack thereof of a winter storm for this Sunday. Now, there's a lot of conjecture out there, a lot of rumors. So I decided to put out this video rather than answering every email I've gotten this afternoon. I understand why there are emails and I understand why there's a lot of questions. There's a lot of uncertainty out there. So I'm going to show you exactly why I don't buy into this major winter storm idea and explain to you basically what I'm looking at and why I feel the way I feel. First, I'm going to start with the actual observations, specifically the water vapor satellite picture in the Pacific. And this is really important because it's a really key factor in understanding how to forecast. You can look at all the models in the world and all the model trends, but if you don't understand what's actually happening now, how can you possibly understand what's happening in the future? More importantly, if you don't understand what happened in the past, as in so far this season, how can you possibly forecast for the future, right? Okay. So what have we been dealing with this winter? Well, unfortunately, as we all know, the winter forecast has been a complete epic explosion of failure. The Pacific has been rather unfavorable, with a huge upper level low in the Gulf of Alaska, which of course has produced a rather progressive Pacific pattern and basically a trough in the west and either a ridge in the east or a trough that doesn't really produce much in the way of storminess for the east. We get some cold air, the cold air leaves, we warm up, we get another rainstorm, and every so often we may get a trace of snow, which the way this winter has been would be considered a major winter storm. So what do we have right now? Well, we have the same progressive Pacific pattern. This is very important. You see these strong winds? These strong winds support a very strong subtropical jet stream. And that's really important because it forces this disturbance right here to not only intensify, but also to continue to move slowly to the east. Notice all the moisture is starting to pick up over the subtropical regions, specifically off the Mexican coast. That is a lot of moisture. That's really important when you look at the models. The idea of a suppressed storm you have to be careful with because you're dealing with a lot of moisture. And sometimes the models underestimate that moisture. So there's that aspect of the storm. The other aspect of the storm that we have to consider is that we have plenty of disturbances crashing into the west coast. And this isn't a situation where you have a strong storm developing over California, let's say, but you still have a ridge over portions of the northern Rockies and Canada. No, we have plenty of disturbances crashing into the west coast of Canada as too. Why is that important? Well, it means that you can't get a ridge in the western United States. I'm going to show in just a minute why that's important. So basically, the way I would characterize the Pacific pattern right now on Thursday evening is very unfavorable for a major winter storm along the East Coast. Now, when we look at the water vapor for the eastern United States, I also have the upper level winds overlaid here. And the reason why is because I want to show the strength of the subtropical jet stream. Notice we have a ridge over the southeast here. We have plenty of moisture starting to bubble up along the Gulf of Mexico here. We have plenty of showers and thunderstorms off the Gulf Coast developing. We have a rather progressive pattern here with disturbances moving from west to east. There really isn't any blocking in the Atlantic whatsoever. This is a progressive pattern. I think we can all agree on that, okay? There's no blocking in the Atlantic. There is no support to, let's say, force a storm to turn the corner and head right up the coast. This is a progressive pattern. We can see that right here. Everything's moving west to east, and it's not moving slowly. It's moving at a nice clip. Same thing with the polar jet stream here. In fact, let's look at the polar jet stream. Let's see, that's this one right here. Here we are. Here we have the 500 millibar pattern from the Penn State EWOL website, an excellent website for observations. And what do we have? We have a weak ridge along the west coast, and we have one disturbance with a subtropical jet stream, and we have another jet stream, the polar jet stream right here. Again, progressive. You know, we have a nice trough, and let me put it this way. If this ridge was building north into the Canadian Rockies with this setup, and then this ridge remained in place and this trough was digging and this disturbance was moving east, then yeah, this would be a prime setup for a potential major winter storm. But that's not happening. The other point I want to make is the air mass in place. This is the current 850 millibar air mass, okay? The temperature environment. And as you can see, all of our cold air is locked up in Canada, and there really isn't much of a push south with this cold air. Yes, we have a nice polar vortex over southern Canada, but that polar vortex is starting to lift north. That's why the Arctic Oscillation Index is starting to rise. And by the way, that's also why we're not seeing a negative NAO pattern to slow down this storm, because the polar vortex is lifting north towards Greenland, and as a result, you end up with no blocking in the Atlantic because you can't get a ridge to build into Canada. So let's take a look at this forecast, and I want to really carefully explain why it's important for why the Pacific pattern is so important as far as its progressive nature. Here we have the GFS, and let's move to 72 hours. Here we are. Now let's move back even further. Let's move back to Saturday night. Now, here is why it's important that this trough is coming in. What I'm looking for in a winter storm, okay, in a winter storm 500 millibar pattern, is a way to slow this disturbance down to phase with this disturbance here, okay? The reason why this trough is important is because you don't have any way to slow this disturbance down. You see, when we look at the upper level winds here, and let's move to 300 millibars, what I want to see is a strong jet streak move down the plains and a similar jet streak move up the coast. You see, that produces a type of upper level wind couplet that forces a surface low pressure to move from the Carolina coast up towards the New Jersey coastal waters. But what we have in place here is a subtropical jet stream that has winds moving from southwest to northeast, not south to north or southwest to north-northeast or something of that nature. And that's important because that means that any low pressure that develops off the North Carolina coast, well, only has one direction to go, out into the Atlantic. Same thing here. It has one location to go, out into the Atlantic. Now, the jet streak here and the jet streak here does support the potential for a rapidly intensifying low pressure system. That I don't disagree with. I have no problem with that idea or that forecast at all. You know, but it does clearly show this low pressure system moving east-northeast. And that's important because that keeps the bulk of the lifting off of the New Jersey coast. Yes, there'll be some rain, but at the same time, it's not going to be the heaviest rain. The best lifting, the best dynamics all support the heaviest precipitation off of the New Jersey coast. Another point I want to make is that there is some guidance out there, let me fix this here, that would suggest that there would be a complete suppression of the storm and the majority of precipitation, majority of the rain even misses New Jersey. The reason why I don't buy that idea is because when we go back to the water vapor, you can see all this moisture being pulled up north. And I think because of this enhancement of the subtropical jet stream, I think we're dealing with a moisture-loaded system and as a result, a more expansive precipitation shield. So, based on the GFS guidance, why do I think that there won't be snow for, let's say, southern New Jersey? Well, here we are on Sunday morning. Now, if you are in West Virginia or northwestern Virginia or portions of southwestern Pennsylvania, I would not be surprised if you get a nice snowfall out of this. I would not be surprised if higher interior locations in West Virginia gets a very impressive snowfall. No doubt whatsoever, in fact. I mean, look at the cold temperatures here. This is the type of storm that could support a heavy snowfall. But this, again, this is the surface temperature, right? This is 0 degrees Celsius at the surface. When we move forward on one of the coldest models, and the model that has been supporting the potential for winter storms, you could see the problem here with forecasting a snowfall for the northern mid-Atlantic. And that is that A, the heaviest precipitation remains off the coast, and B, the coldest temperatures remain over the interior. Below freezing temperatures remain to the north of the heaviest precipitation. Now, for portions of southeastern Pennsylvania, we might have to watch out for a little bit of light snow mixing with this rain based on the GFS guidance. Not sold on that 100% yet, because I think that some of this precipitation is going to fall away due to dry air invading from the west. But because we don't have a full phase here with the polar and subtropical jet stream, this cold air is going to lag back. It's going to remain over portions of, let's say, central New York and central Pennsylvania. So as a result, you're going to get a nice rain event over the coast here, especially over southern and central New Jersey. But the potential for snowfall is limited, possibly to the interior locations of southeastern Pennsylvania for the northern mid-Atlantic, for the Philadelphia and New York City metropolitan area. Based on the GFS guidance, and really if you want to go really extreme, go with the European model guidance, which almost has a complete miss. I really think that Connecticut, much of the New York City metropolitan area, misses out on the brunt of this storm. It'll be windy, but I think you're going to miss out on the majority of precipitation. And I think the bullseye for the most significant impacts with this storm will be central southern New Jersey and southeastern Pennsylvania, with a good potential for most locations seeing rain out of this. And we're going to have to see maybe a light snow event possible for southeastern Pennsylvania. Talking about Allentown, Reading, Lancaster. Could see a light snow out of this if we go verbatim on the GFS. Still, I want to stress this. We are still several days out. There's plenty to watch here with this storm. But based on the observations I'm seeing here, the two options I think are most realistic going forward with this storm is either a complete miss because this storm just gets forced to the east because of this disturbance, or a heavy rain event for much of the coastal plain and maybe a rain-snow mix for the interior. I think that it only moves as far north as, let's say, about the New Jersey coast. I think that the track that the GFS currently has is going to be the right one, but the question is just how much of a precipitation shield is able to expand with this storm. Right now, again, I do think that there's going to be plenty of moisture with this storm, but I think that it's not going to be able to move as far north as some think. And no, I do not believe this is going to be a major winter storm as far as heavy snowfall, because the cold air is arriving too late, and the subtropical jet stream is going to be the dominant one here, with more warm air influencing this storm. So again, pretty much what we've been dealing with all winter will continue to remain an influence on our weather pattern. For the most part, we're dealing with rain here, possibly mixing a little bit of snow in the interior. Could be a light accumulation depending on the timing of this cold air invading from the west, but most locations will remain wet with this storm based on the latest data this evening. So that is my thoughts right now as of this evening. Of course, I'll keep an eye on this storm and have more updates early tomorrow morning as the 0Z model guidance starts to roll in. This is your meteorologist, Stephen DiMartino, for NYNJPA Weather. Have a great evening.